As soon as the inverter is connected to the battery, the positive voltage flows through the center tap of the transformer and waits at the drain of both MOSFETs. At the same time, the battery's positive voltage also flows into the common terminal of the 6-pin switch and waits for the inverter to be switched on. Simultaneously, the negative voltage from the battery reaches the inverter circuit board. In addition, the source terminals of the MOSFETs are also connected to the negative voltage. When we turn on the 6-pin inverter switch, the positive voltage passes through the switch and reaches the power diode on the inverter board. At this point, the inverter circuit begins to operate. I'll go into more detail about the ICs and other parts on the inverter board and how they work together. The primary controller, the 4047 IC, features a 14-pin configuration. Pin 10 is the main output and is used to drive the gate of the first MOSFET. Pin 11 is the inverted output and is used to drive the gate of the second MOSFET. For a 50 Hz frequency at pins 10 and 11, simply install a 104 capacitor across pins 1 and 3 and a 45K resistor across pins 2 and 3. A 9-volt Zener diode and 470 ohm resistor are required to provide positive voltage to the IC. For the positive power connection, pins 4, 5, 6, and 14 should all be tied to the positive rail. In addition, you should connect pins 7, 8, 9, and 12 to the negative rail of the power source. As soon as the inverter switch is turned on, power reaches pin 14, and PWM signals start generating from pins 10 and 11. The PWM signals alternately switch the gates of the two MOSFETs on and off. This triggers the flow of electricity from the drain to the source, starting the switching process. The 220 ohm resistor functions to turn the gate on, while the 10K ohm resistor assists in pulling the gate back to ground to turn it off. When the MOSFETs are toggled by the PWM waves, they generate alternating magnetic fields within the secondary transformer windings. The magnetic induction from the primary winding produces a massive magnetic field in the secondary winding thanks to its high number of coil turns. As the magnetic polarity in the primary winding alternates between north and south, the secondary winding's magnetic field changes in the same way. Thanks to the continuous change in the magnetic field, we have successfully generated a 220-volt 50 Hz AC waveform. But keep in mind, because we use the 4047 IC, the output is still a square waveform, which is mainly ideal for powering lights. Ground.